Okay, here's the test without showing it on the video. But you can see it. Okay, and I'll read every section off to you basically so you understand. And the first 4 are going to be like these. Okay, Arrhenius or Bronsted, we'll go over that in a minute. The next 10 or so, 11, are going to be questions on the properties of acids, bases, indicators, things like that. It's going to say, fill in the blank with A for acid, B for base, or I for indicator. All right. You should know that which ones are slippery, which ones are sour tasting, bitter tasting, turn litmus red or blue. Indicators like what are some examples of indicators we used this year already? Some examples of indicators: phenolphthalein, Congo red, litmus, purple cabbage, tea. Okay, so all that stuff. Next section, that's the first 2. Third section, 3 problems like this. 3 neutralization reactions where, they're going to be worth a lot of points, I'll tell you right now. You have to complete it, name everybody, each thing's worth a point. Bottom section, normality chart. Now, I only did one, I didn't put a chart up here, it wouldn't have fit, but I did one question on normality, all right, right here. I gave you mass, you had to calculate molarity, and then turn it to a normality. Well, the chart's going to be forward or backward. I'll give you some molarities, you have to get the normality, I'll give you some normality, you get the molarity. You have to use the formula. All right, the formula as in how many H's, how many O's. All right, so that's the front side. There it is. Back side, still a lot of stuff. We got to cover the next top of the back side. Probably the first 5 are just naming or writing formulas for these guys. By the way, so there was only 5 of that. We did a lot of naming and writing. Don't forget that also shows up here, doesn't it? You have to name and write the formulas for those guys as well. Okay, so they're going to see quite a bit of naming and writing acids and bases. Then there's some questions on the strengths of acids and bases. Can you pick out the stronger or weaker one? Based on the binary acid, electronegativity, stuff like that. Central atom, oxidation number. You'll also have the next question be on some conjugate acid-based questions and amphoteric stuff. Short answer question on one of those. The other one, let's see, there's one normality problem like this one, 2 pH problems like these, and 2 titration problems like this one. All right, so I've got it well represented up here. Pretty much everything that's on the test is up on this board, and you have to be able to do all of it correctly, though. Now, I can't help you with some of it, but I can help you with most of it in this case. This time, this test, most of it, 80% probably, I'm going to be able to go over right now on this board. All right, the stuff that I can't, stuff down here, properties, amphoteric, things that you're going to be asked questions about. All right, let's start with this first one. When you do these, let me do this first one showing you the kind of mistakes you might make if you're not paying attention, if you're not doing it right. You might just write down K. Well, first of all, you should know you're going to take the positive ion from the base and the negative ion from the acid. So you might write down K, SO5 plus H2OH. And that's what I'll get for a very bad answer. Okay? I'm not going to get a whole lot of points for that. Okay? Potassium's +1, SO5 is -2. You should have written K2SO5. Water's formula did not suddenly become H2OH. What's the formula for water? H2O just, okay? All right, and lastly, I have to balance it. I've got 1 K here, 2 Ks there. I'll put a 2 there. I'll need a 2 in front of there to give me the correct number of H's and O's. All right, now you've got half your credit. It's only half. I still got to name him, name him, name him. Okay? So H2SO5 is called what? By now, you should not be doing that. Should not be persulfic. You've heard me say, and you've written down, and I've corrected you enough times that you should know it's not sulfic acid. It's sulfuric acid. You've heard that word 100 times. You saw it in the video just yesterday. All right? And I've corrected it a bunch of times. In the beginning, I wouldn't have taken off for it, but at this point, the test is tomorrow. You should know there's 2 guys. Phosphorus is the other one. I wouldn't call it phosphic acid. What would I call it? Phosphoric. Okay, you got to know that. KOH, potassium hydroxide. That's easy. So persulfuric, by the way, back to the persulfuric. Why is it per? Because the one on the sheet, the root word of the sulfate ion is SO4. That's one more persulfuric. K2SO5, I know I'm going to get this tomorrow. I could say this 1,000 times. I will still get someone who will write down potassium persulfuric when the correct answer is potassium persulfate. It is not potassium persulfuric, despite your best attempts to try to make it that. Look if you did that. Okay? All right, it's only sulfuric acid when it's an acid. H is the first element. If anything else, it's a salt, and it's called 8 per sulfate. All right? Okay, good enough. Now I know it's a little confusing with the rules. I mean, here it's per sulfuric, there it's per sulfate. Why isn't it per sulfurate? All right, I know that, but you realize there's only a couple of guys that are a little weird. All the other ones are pretty simple. All right, let's do this guy. Arrhenius and Bronsted acid bases. I recommend to you that you simply do the Bronsted first. It always gives you the best idea of who's the acid or base, and it's the easiest to see. You watch the H's, watch the protons. Here I've got H2O, there I've got OH. Oh, he lost an H. Here I've got NH3, here's NH4. He gained one, so this H went over there. He donated, it makes him a Bronsted acid. He accepted it, makes him a Bronsted base. That you probably won't get wrong. What will you get wrong? You'll probably get wrong the Arrhenius. Where to put him? Is there an Arrhenius base or an Arrhenius acid? In this case, since there are OH ions formed, there is an Arrhenius base. Who is he? NH3 is the Arrhenius base. And let me explain to you one last time, although I said it multiple times already. He's the Arrhenius base, not water, for 2 reasons. One, the definition of an Arrhenius or Bronsted acid or base is a guy who, when you add him to water, when you dissolve him in water, when you react him with water, he forms hydroxide or hydronium ions. So it can't be the water itself. Water is never the answer for Arrhenius. Secondly, if I were to have called this guy an Arrhenius base, he would have been both a base and an acid at the same time. That's not possible. Okay, at the same time. However, I'm going to erase all. It's going to be messy up here. You will notice something about water. In this problem, he was donating an H. In this problem, he's accepting an H, right? Which makes him a what kind of compound? What's that word? Amphoteric. He can do both, but he can't do both at the same time. He can accept, make him a Bronsted base here. He can this guy's donating, making him a Bronsted acid. I also have hydronium ions for him, which means I've got an Arrhenius acid around here somewhere. Who is it? HClO3. Not water. Who said water?
He said not water.
Not water. Very good. Okay. Arrhenius acid. All right. Not water. That's not a really good answer, though. I mean, you got to say which one it is. And by the way, could you name each of these guys? What's his name? Chloric acid, right? Not hydrochloric acid. Okay. Speaking of which, let's get to naming some acids and bases and writing the formulas for them. H2SO2, what's his name? Hyposulfurous. Good. How about HNO4? Pernitric. Now look, here's your basic rundown here. You have your root word. You have 1 less oxygen, 2 less oxygens, and 1 more. Root word, he is whatever he is on the one of the common ion sheet. It could be SO4, it could be whatever, SO3 or NO3. 1 less, I'm going to call him OUS. This guy's going to be ick. This guy's going to be what? 2 less. Hypo-us. And this guy 1 more? Per-ick. All right. And that's basically, you have to know that. Now, it's not much different than the previous time we had this when it was for the polyatomic ions. All right, so it's not much different than that. H2CO2, what's his name? Carbon-us, OUS, right? Okay, because CO3 is on the sheet. Hydrosulfuric acid would be HS, right? It's binary. Got to use a charge. It's +1, -2, H2S. Good. Yeah, hey. Oh, yeah, it's all back. They're all back there. Aluminum hydroxide, I think everybody's going to be able to do that guy by now, right? Although you do have to use the charges, +1, +3, -1. Ammonia. Many people had this wrong. They're all on the individual tables. Ammonia is not NH4. I got that last time. That's not ammonia. It's NH3. Why do everybody write down NH4? Because they're looking at the common ion sheet. That's the charge. That's the polyatomic ion formula, NH4. That's the ammonium ion. Not ammonia. That's after he's already accepted an H from somebody else. All right. H3P, what's his name? Hydrophosphoric. Not to be confused with phosphoric. Phosphoric acid would be HPO4 with +1, -3, H3PO4, right? Okay? We're good? What else? That's it for that one. Now, the next one is what? Oh, what kind of problem? I get people all the time who do this on this one. They look at this problem, and its first words say, find the normality of the base. So you know what? They start doing it like a normality problem. I have to do like, moles per liter and then multiply. No. What kind of a problem is this? This is not asking you to find a normality given grams dissolved in water. It's a titration problem. And I have people all the time who do these as normality problems. They're not. This is Na, whoops, Na, Va, Mb, Vb. You can use that cart if you want. That one right. Just take it down. All right. Look for all the stuff up here. Normality of the acid. Up there it's 0.40 molar, but I got to multiply him by 2 because I've got H2SO4. That makes it 0.80 normal. The volume of the acid is what? 30 milliliters. Normality of the base? What we're looking for, find the normality of the base. Volume of the base? 12.0 milliliters. NaVa equals NbVb. And I'm solving for Mb, so I'll divide both sides by Vb. There's my equation. All right, so my Nb equals, Na is 0.80 normal. Va is, 30.0 milliliters. And then 12.0 for the Vb. Milliliters cancel, leaves it with normality. What is my normality? What is it? 2.0? 2.0 normal. And that's all it asked me for, so I'm good. The next one's going to ask me for, actually it's going to give me, ask me for one of the ones I've done in the past. Say, for example, it wanted the molarity, and it told you the base was CaOH2. What would you have to do there? You'd have to divide by 2. Yeah. You guys want to move over a little bit so she can get this?
So stay tuned for information.
Yeah, you're doing those are the right concentrations for the volumes I gave you on that sheet, because I just did that lab. I'm going to do that lab with them tomorrow. Not these guys, but the other class, they have a double. So if you can be, if you're using the same ones, just realize something.
I'm doing this one.
Right, that's the same one I just did. That's the same one. Some of those are already filled up, waiting to go. But yeah, as long as I have enough, you're only doing one class of it, there should be enough. If you find that there's like almost nothing left in these, just drain maybe a couple of them that you're sure that back into the bottom of the acid scans. I just need to do one more lab. All right. What's next? Let's see. I do have a problem where I am solving for normality here. I'm giving you grams and I'm giving you volume, right? So I've got to do that too. Solving first of all for the molarity. Okay. M is moles of solute per liter of solution. Show me the work. You can abbreviate a little bit like I'm doing here, but you got to show the work. Moles, well, I got 25.0 grams. Grams at the bottom, moles at the top. 1 mole contains 74.01 or something like that, right? How'd you get that 74? You added up calcium, 2 oxygens and 2 hydrogens. Liters, 3.0 liters. What do you get for your molarity? What is it? Well, what is the molarity? Just the molarity. 0.112 or something like that?
Yeah.
All right, if it's 0.112 molar and it's calcium hydroxide, I'm going to multiply that by 2 and get 0.224 normal. Okay? Got it? All right. I have one more to do. You watch it?
No.
Watch.
You're like, no.
Now this one I actually want to spend a little bit of time on, because if you look at your papers, very few people got 10s out of 10 on this. Sometimes it was just for significant figures, but not all of the mistakes were significant figures. A lot of their mistakes had to do with the fact that, if you look up here, this guy's concentration is of a base, not an acid. I can't just plug this number into my pH problem. Okay, I also can't just plug them in for another reason. There's a 2 after them. All right, so for both of those reasons, I'm going to have to, well, I want you to always show me the formula and the equation. This guy's breaking up. A base breaks up in water into magnesium ions in this case, aqueous, and hydroxide ions, aqueous, right?
Yeah.
But I have 2 of these, so I need a 2 in front of there. You would have done this last chapter. Now, I'm told I have 0.000250 molar of that, which means I have 0.000250 molar of that, but I have 2 times 0.00025 molar of this, which means I have 0.00050 molar. Got it? That's your hydroxide. So you remember to multiply by 2. That's one thing. The second thing, if you look at your papers, that many people did that, they then went and said, okay, pH equals negative log of that. Well, it's not. It's not negative log of that. It's negative log of the hydronium ion concentration. I don't know the hydronium ion concentration yet. I got to find it. When there's trouble, you call KW, hydronium times hydroxide, equals KW, the ion product constant of water, which we know to be 1 times 10 to the negative 14. Now, we have to rearrange this equation and solve for hydronium, so I'll divide both sides by hydroxide, and hydronium will be KW over hydroxide, which is 1 times 10 to the negative 14th molar squared over 0.000500 molar. What's my hydronium ion concentration? 2.00 times, and by the way, significant figures do count as well, times 10 to the what? Negative 11th? I told you not to use that 1 times 10 to the negative 14 as your significant figures. Use what you're given in the problem. All right, that's the number that goes in here. So it's the negative log of 2.00 times 10 to the negative 11th. What's my pH in this problem? What is it? 10.7. Everybody get that? Now, here's the thing. When you did that paper, the worksheet, you guys did together in class, just working out together, but you were working on it just in class with your notebooks open. You got an answer, many people got an answer of like 3 point something for a problem like that. That should be a dead giveaway. It's the wrong answer. Why? Because you were doing it for a base. Can a base have a pH? Okay. Can a base have a pH of 3? No. A base isn't going to be a pH of 3. All right, so that should be a dead giveaway that you had a mistake somewhere in there. All right, that's it. That last one? Yep, just in time. Almost out of time.